Circular sliding window over two-dimensional array algorithm. Here is your same structured beginner-friendly content for circular sliding window over 2D array, advanced level, grid-based optimization, introduction. Sliding window is a powerful technique used to efficiently process subarrays or substrings. In advanced problems, this concept extends to 2D arrays, matrices, circular structures, wraparound behavior. A circular sliding window over a 2D array means moving a window across a matrix, allowing the window to wrap around edges, efficiently computing values inside the window. This is useful in image processing, game grids, heat maps, toroidal, wraparound, systems, advanced algorithm design. What is circular sliding window 2D? A circular sliding window in 2D means selecting a submatrix that can wrap around both rows, columns. In simple terms, circular 2D window equals window that continues from one edge to the opposite edge. Core idea. Index equals I mod n, j mod m. Index equals I mod n, j mod m. This allows the window to loop around the matrix. Why circular behavior is needed. In many real-world problems, edges are connected. Data repeats cyclically. Boundaries should not stop computation. Example concept. Right edge means wraps to left. Bottom edge means wraps to top. This forms a toroidal structure, like a donut. Difference. Normal versus circular window. Normal sliding window stops at boundaries, cannot exceed array limits. Circular sliding window wraps around edges, continues computation. Example concept. Normal means limited. Circular means continuous. Problem definition. Given a 2D array matrix window size, k times k or h times w. Find values, e.g. sum, max, for all possible windows, including those that wrap around. Key challenges. Circular 2D sliding window introduces complexity. Handling wraparound indices, avoiding duplicate counting, maintaining efficiency. Example concept. Wraparound logic means tricky indexing. Approach 1, modulo indexing. Core technique. Use modulo operation to wrap indices. Formula. Rho equals I plus x mod n, col j plus y mod m. Rho equals I plus x mod n, col equals j plus y mod m. This ensures indices always stay within bounds. Window wraps naturally. Approach 2, matrix expansion trick. Instead of handling modulo manually, duplicate matrix in both directions. Idea original means expanded matrix 2, n times 2, m. Now apply normal sliding window on expanded matrix. Example matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Circular window example 2 times 2 starting at edge 3, 1, 6, 4. This wraps from right edge to left. Sliding window workflow 2D circular. For each cell, ij, expand window of size k times k. Use modulo for wraparound. Compute result, sum, max, etc. Naive approach is slow. To optimize, use prefix sum 2D. Use incremental updates 2D prefix sum optimization. Sum x1, y1, x2, y2 equals px2, y2 minus px1 minus 1, y2 minus px2, y1 minus 1 plus px1 minus 1, y1 minus 1, y1 x2, y2 ya2 px1 minus 1, y2 minus px2 y1 minus 1 plus px1 minus 1 y1 negative 1. But circular cases require adjustments. Java implementation, basic circular window sum. Public class, circular 2D window. Public static int, get window sum, int matrix, int start row, int start col, int k. Int n equals matrix.length, int m equals matrix.length, int sum equals 0. For int I equals 0, I equals k, I++. For int j equals 0, j equals k. Int row is the start row plus I %n. Int col is the start col plus j %m. Sum plus equals matrix row col. Return sum. Public static void main string args int s dash matrix equals 1 2 3 4 5 6 7 8 9. Int k equals 2. 4. Int I equals 0, I less than matrix length, I++. For int j equals 0, matrix 0 length, j++. Int sum equals get window sum matrix I j k. System out print line, start plus I plus j means sum plus sum. Time complexity, naive approach, on times m times k times k. Optimized approach. With prefix sums. O, n times m. Real-world applications, image processing, blur filters, convolution operations, gaming, wraparound maps, toroidal worlds, data analysis, heat map analysis, cyclic patterns. Example concept. Circular grid means continuous analysis advantages. Advantages include handles cyclic data, efficient grid processing, avoids boundary limitations. Example concept. Wraparound means seamless computation limitations. Challenges include complex indexing, harder debugging, optimization difficulty. Example concept. More flexibility means more complexity. Concepts learned. Circular indexing using modulo. 2D sliding window. Prefix sum optimization. Handling wraparound grids. Advanced matrix traversal. Simple definition. Circular sliding window, 2D. A technique where a window moves over a matrix and wraps around edges using modulo indexing. Final summary. Circular sliding window over a 2D array extends the traditional sliding window technique by allowing wraparound behavior. Using modulo indexing or matrix expansion, we can efficiently process cyclic grids. This technique is widely used in image processing, gaming, and advanced algorithm design. Understanding this concept is essential for mastering advanced data structures, matrix algorithms, and optimization techniques.